Okay, so we're going to finish up here our Euler's line series, these couple of videos working through the centers of a triangle. Let me show you the original problem we started with. We had this question that said, okay, here's 3 points, and we want you to find the equations of the altitudes. Altitudes, which are the lines that go from the vertices down through the triangle at a 90-degree angle to an opposite side. We found those equations. They meet at the orthocenter. We found that. In the last video, we found the medians of all 3 sides. This is the line going from the middle, right, of each line over to the vertice, which is sometimes at a right angle, sometimes not. It's not the exact same thing as an altitude because it has to cut the line in half, but it doesn't have to cross the line at a 90-degree angle. If you do a triangle like this, right, of course, a median going from here to this point, it'll cut this line in half, but it's certainly not at a right angle. But these lines, when we found those, let's call this centroid. We found that next. Here's our sketchbook on that one. Right, we found the centroid eventually. And here's O, our orthocenter. We found that as well. So all this sketchwork got us those 2 points. So I'm just saying now we have 2 things left, and we're going to do them in one shot: the circumcenter and Euler's line. Now, to help us, right, well, of course, I'll remind you what the circumcenter is and all that, but let's just take a look at a cleaner diagram. So here, less exciting, but the same triangle with the points C and O labeled. So as I just said, C is going to equal our centroid, right, which we just found, and that point value was 5 1/3. Right, and 4. And then O will equal our orthocenter. And that's the first thing we found, and that's just equal to 6, 2. So now we have these 2 points. Our job now is to find the circumcenter. Now the circumcenter, we'll work on in purple here. Right? The circumcenter is next. What is the circumcenter? Well, the circumcenter is a pretty, I think, neat idea. The idea is it's the intersection of the perpendicular bisectors. So it's the intersection of the perpendicular, I'll use the symbol, a perpendicular sign, bisectors. What does that mean? Well, again, bisectors cut lines in half. So we know a little bit about this already, because in the last video, to find the centroid, right, we used the median. Same idea now, except not only are they crossing at the median, but these lines are crossing at a 90-degree angle. Let's take a quick peek back here. You see, well, you might not be able to see it because it's a little messy, but here's one median at 3, 6. So let's go label that. 1, 2, 3, and then up 6. So we know that one of the perpendicular bisectors has to cross through the point M1, we'll call it. M1, as we did in the last video, it's 3, 6. And what else do we know? Well, we know that it has to cross through 8, 6. 8, 6 is the median of this side. So we go here, we draw out 8, 6, here's 8, and then up 6, the same height as the other one, right? 8, 6. This is our second median. I think I called it that at least. Let me just check it out. We didn't number them over here, but oh well, I'll call them M2 over here, and that's 8, 6. And then the last median down here on the bottom is just our third median. It's at 5, 5, 0. 1, 2, 3, 4, 5. All right, so there are 3 medians, and the point is that the perpendicular bisectors now, they will be at 90 degrees. Right, to each of these sides. So here's one, maybe. Here's another. Fix that. Try to be as accurate as possible here. There's one. There's another. Out here. So this point, this is a rough estimation here. This is the circumcenter. I'll put CI. This CIR, the circumcenter, is the intersection of these 3 points. And notice perpendicular bisectors don't necessarily go back to the vertex, right? They don't cross the vertex, but they do cross these lines at right angles. So typically what I would do to find the circumcenter, right, is to find the equations of these three lines, right, as their perpendicular bisectors, find the equations of these three lines, and then figure out where they cross, and that gives me a point. But maybe there's another way of looking at it, and that's where Euler's line comes in. And the fascinating thing about Euler's line is that there are always certain centers of triangles that are on this line. Specifically, in this case, the centroid, the orthocenter, and the circumcenter. They all form a straight line. What does that mean? Well, I mean, I'm jumping around here, and you could find the circumcenter by just finding the equations of these three perpendicular bisectors, right? They have the negative reciprocal at the slope of each line, and they cross the median. And we've done most of that math already in the past video looking at that. We know the slopes of these lines, so we know the negative reciprocals, and we can use that information. But another way of thinking about it that I think is exciting is to say, all right, how do you form a line? How many points do you need? You only need two. Once you have these 2 points right here, right, and we know they're going to be on the same line, we can tell what the equation of the Euler's line will be by using the centroid and orthocenter. Right? We can find the slope. Let's find the slope of Euler's line. And that'll be delta y or delta x, of course. Right? And we know that we're comparing the orthocenter and the centroid to delta y, 4 minus 2, which is 2, over 5 1/3 minus 6. And we work as a fraction here. So 5 1/3, that's 16/3. Minus 6, that's 18/3. Now give me 2 over what? Well, 16 minus 18 is negative 2/3. So to simplify this, I'm just going to multiply everything by 3. So by 3 and by 3. I don't want to change anything, so I multiply by 3 over 3, which is just 1. But 2 times 3 is 6. So the slope of E will equal Euler's line will equal 6 over negative 2, or that's negative 3. So this line has a slope of negative 3, and that's about what I have here, right? It's a pretty rough sketch, but it's on it, it's close to it. And I want to write Euler's line in slope-intercept form. So if I know that these 2 points are on the line, I know I can plug these x and y values in to find out the y-intercept, because that's what I'm missing. I have the slope. So of course y equals mx plus b, right? That's the slope and intercept form. The slope is negative 3. And I know that the orthocenter is on this line, so I'm going to plug in this 6 for x and this 2 for y. So 2 equals slope negative 3 times 6 plus some b value. Don't confuse that b and 6. So negative 3 times 6 is negative 18. Plus b, we're going to solve for b equals 2. Add 18 to both sides, and b equals 20. All this means now is I have my y-intercept, I have my slope. We can write Euler's line. Euler's line is written as y equals negative 3x plus 20, right? Because these points are on the line, I can use these 2 points. Now the circumcenter, right, has to cross this line, right? Wherever the circumcenter is, I know that if I have one perpendicular bisector, it must, right? It must cross this line, Euler's line. The question is, where does it cross? Well, we can figure that out. And here's how I might do it. Let me use the perpendicular bisector to one side. I'll just choose the perpendicular bisector at this median right here. So what's the slope of this line? What's the slope of BC? Just to go back. I think we have it earlier on. I have it here. Yes, although there really is a mess here. The slope of BC, right? Well, I guess I lost it. So I had it written before, but just recalculate it. What's the slope of line BC? So delta y, delta x, the slope of BC. Well, delta y, it's 12 minus 0. Delta x, 6 minus 10. So that's 12 over what? Over negative 4. So the slope of BC is negative 3, which means the slope of the perpendicular bisector has to have a negative reciprocal of that. So the slope of this bisector, we call it P1, or perpendicular bisector 1, right? That slope has to equal positive 1/3. Like the negative reciprocal of negative 3. It's positive 1/3. X plus some b value. How do I find that out? Well, I know that this midpoint here is on this line, so I'll plug in this x and y value. So it's, right, this perpendicular bisector, what I can say is that y equals 6, so y equals mx plus b equals mx, so m is 1/3, times x, which is 8, plus b. And I'll just solve for b. So 6 equals, this means, of course, 6 equals 8/3 plus b. If I subtract 8/3 on both sides, I get that b equals 6 minus 8/3, and I'll write that as 6 as 18/3. If I subtract here, 6 minus 8/3, and that's going to equal b. So we're almost done here. Hang in there. B is equal to 10 over 3. So this perpendicular bisector right here has a y-intercept of 10 over 3, which is a little bit above 3. And if my drawing is a little more accurate, that would show. So anyway, the equation here for the perpendicular bisector is what? Well, this perpendicular bisector is 1/3 x plus 10/3. So this now has to meet Euler's line, which is we have the equation for up here. So at some point, right, and this is how you define the circumcenter, this perpendicular bisector has to meet Euler's line. Well, that intersection must be the circumcenter, right? Because these bisectors are meeting together at one point, and because that point is on Euler's line, if I find where one bisector meets Euler's line, I found the circumcenter. So I'm just going to solve for x. Set the perpendicular bisector equal to Euler's line. So let me just move this down here so I can put them together. These two things are going to be equal. And actually, it wasn't right here. So I ran out of room. Let me just clear up some space here. We don't move this anymore. Okay. So what do we do? Well, this is just a basic solving for x situation. So we have negative 3x plus 20, that's Euler's line, has to equal this bisector. 1/3 x plus 10/3. Solve for x. What do we do? I'm going to subtract 10/3 from both sides. Right? Subtract 10/3. And I'm going to add 3x to both sides. All at once. What does this do? This cancels out, and this cancels out. So I have 20 minus 10 over 3. Well, 20 in terms of thirds, what's that? Well, 20 times 3 is 60. So it's 60/3, it's 20, minus 10/3 should equal, well, what's 3 plus 1/3? It's 3 1/3 x. Keep going here. And we want to solve for x, actually, right? I'm going to rewrite x in terms of thirds in a moment. So 50 over 3, 60 minus 10 is 50, equals 10/3 x. So what does x equal? Multiply both sides by 3 over 10. And this starts to cancel out now. It's nice. These cancel out. It's just 1. 3 divided by 3 is 1. 50 over 10 is 5. So the x value is 5. That makes sense. You can see from the specs it's about right there. It's at 5, and then some y value. So here, this is on Euler's line. I could use either equation here, but I'm going to use the one without a fraction in it. I'm going to plug this x value into Euler's line to find the y value. So we have negative 3 times 5, that's our x value, plus 20. What does that equal? Negative 3 times 5 is equal to negative 15, plus 20 is equal to 5. So when x equals 5, y equals 5. That's kind of remarkable, actually. I think it's just remarkable because, well, we have all these numbers working out to a nice whole number solution. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's our circumcenter. So this circumcenter, this centroid and orthocenter are collinear. And that's the wonderful surprise, I think, of Euler's line. And this is for any triangle. Anyway, this was a long series. I hope you enjoyed it, and I hope it helped. Thanks a lot.